Okay, so covalent bonds are very, very strong, but the forces that attract between molecules are very weak, and this is um, they're very weak. They're weaker than the formation between cations and anions in ionic compounds. Okay, and this is pretty evident when we boil water, right? Pretend these are water molecules, which they are. Okay, you have your one oxygen, your two hydrogens, and this is how water would look when they're bound together, right? This hydrogen would be attracted to this oxygen would be attracted to this hydrogen because of its affinity, its charges. But don't worry about that. Okay, to be attracted, these ones would be attracted. But these bonds right here, okay, are very, very strong. The bonds in between this water molecule and this water molecule are very, very weak and very easy to break. Okay, and that can be seen when we are boiling water. Okay, so weak bonds attracting one molecule to another molecule, strong covalent bond holding individual molecules together. Okay, so the individual molecule covalent bonds are very strong. The molecular bonds are very weak. Okay, so for example, the heat required to boil water is not sufficient enough to break down the the covalent bonds that hold the hydrogen to the that hold the oxygen to the hydrogens. Okay, but it is strong enough to break the bonds between water molecules. Okay, just like I said there. Okay, so notice that individual water molecules remain intact. Okay, so when we're boiling this water, you're just getting the bubbling and the formation of vapor uh, by separating water molecules from one another, but the actual water molecules are not separating themselves. Okay, so molecular compounds have several common physical properties. They have a lower melting point, less energy needed to break attraction between molecules as compared to ionic compounds. Ionic compounds, you need a lot of energy in order to break the attraction between the anion and the cation, but in molecular compounds, you do not need a lot of energy to break the bonds between each molecule. You need a lot of energy. You can't break apart the covalent bond, but you can break apart the bond between each molecule. Okay, and they do not conduct electricity, contrary to what you might believe. Okay, water does not actually conduct electricity. It's the electrolytes and the sodium and the potassium or calcium that's in the water that conducts electricity. Okay, they do not conduct electricity when solid, liquid, or gas. Okay, they do not contain ions. Ions are necessary for the conduction of water. That's why it's not good to go swimming in an electrical storm in, say, your pool or in a lake, because the lake has lots of ions in it, and those ions are what conducts electricity and allows the electricity to flow in water extremely fast. Okay, electrolytes versus non-electrolytes. A substance that dissolves in water to produce a solution that contains electrolytes is an electrolyte. So you have your Gatorade. Gatorade has a lot of sodium and a lot of potassium in it, and that those are the electrolytes that your body actually needs in order to survive. Okay, if you drink too much water, what happens is you dilute the amount of sodium and potassium, and you can potentially pass out or faint. Okay, this has a lot of ions in it, electrolytes. Okay, this has somewhat. Okay, see how it's all dissolved and some disassociated, and it allows for electricity to jump from ion to ion to ion. Where the weak one here, okay, it has a couple that are unbound, but some that are some that are bound, some that are unbound, and electricity can flow from ion to ion to ion, but not to these ones here because they are electrically neutral. And then here, say you just had pure water or whatever this might be, say carbonated pure water. Electrolytes, there's no electrolytes, there's no sodium, there's no potassium, there's no charges inside of this beaker, meaning that their electricity will not be conducted through that. Okay, so ionic compounds can be electrolytes if they dissociate, and molecular compounds are non-electrolytes. So if you just drop a cube of salt, you're going to get some dissociation between the sodium and the chlorine in the salt, in the water. Okay, but it's less conductive when compared to, say, I stirred that salt and broke apart all those bonds, ionic bonds, and made that. So the more disassociation that occurs within an aqueous solution or within water, the more chance of conducting electricity, the higher the conductive properties are of that. Okay, so like I said, here every single piece is completely dissolved. Um, can, every piece or every ion can conduct electricity. Here, these ones can't, but these separated, dissociated ions can, and in a molecular compound, you cannot. Okay, so I hope that makes sense. If you have any questions, just let me know.